How do you answer questions from C5, which is all about energy changes in chemistry? Let's go to work on this. Roll that graphic. Hi, I'm Paul. This is Science That Sticks, and in this session, I'm going to show you what equipment is always required in those questions, what sorts of reactions there are, and why they tend to mess around with other modules where there's other chemical reactions taking place. So let's have a look at the kit that you'll need for these sorts of questions. So normally there's an experimental question. You'll be asked, of course, about the control, the dependent, the independent variable. That's fine, and not the scope of this particular video. You will need to show that there is an insulated beaker. That might be a styrofoam beaker, which is an old-fashioned type of plastic. The reactants are inside. There's a thermometer, there's a lid. The insulated beaker prevents heat loss. The lid also prevents heat loss to the surroundings. The thermometer allows you to take temperature readings. The stop clock allows you to take temperature readings at certain points. So here's what you would typically do. You would have reactant A placed inside the reaction vessel, the insulated reaction vessel. You put the thermometer in and you would start the stop clock. You might measure the temperature every 10 seconds for, let's say, 60 seconds. At 60 seconds, you add reactant B. Put the lid on, you stir it, you keep the stop clock going, and you record the temperature again every 10 seconds. So that will be 60 seconds, then 70, then 80, and so on. Now you will see a temperature change with the readings, okay? Once the temperature has gone up as far as it needs to, or has dropped as much as it needs to, and starts to change direction again, give it another minute or so after that, and then stop, repeat, take an average, and you're good. You're finished, really. Now, what typically will you be asked to do? Well, you'll be asked to explain what they changed, what they kept the same. Now, in this case, there's a couple of terms that you really need to identify. The first of which is not amount. Don't use the word amount. The word amount should be banned from GCSE students. Okay, don't use the word amount. Use volume or mass, but don't use amount because it's too vague. So, the volume of the liquid, the mass of the solid, hell, even the mass of the liquid, if you so desire, the concentration of the acid, the concentration of the dissolved substance. Voila. Those are things that you would keep the same, but they're also, one of those things is what you would change. What you are measuring is the temperature. Voila. Why would you use a thermometer? Well, it gives you good results, but what's even better than a thermometer is a temperature probe. Now, what are the reactants? What are the reactions? Well, the first one is neutralisation. Now, the required practical for this happens to be hydrochloric acid with sodium hydroxide, and you get sodium salt, and you get water. You would place the hydrochloric acid, whatever concentration it is, inside the reaction vessel, start the stop clock, take the temperature for a good minute or so. It will be the same, and that will be room temperature. Then you add the sodium hydroxide. You do not stop the stop clock. It keeps running because you can't pause time. You're not that good. And so you allow the temperature to change. You take the readings, you give it a good old stir, and then once the temperature change looks like it's heading back to normal, voila. So the first one of those reactions is neutralisation. The second one of those reactions happens to be a displacement reaction. Both of these types of reaction happen to be from C4, chemical changes. Okay, so when you're doing an assessment for C4, quite often they ask you about temperature changes. And you'll be like, why is it doing that? And it throws you out, and vice versa. So don't be thrown out by this. So displacement reactions, generally speaking, the more pronounced the change in this, the further away the reactivities are with the displacement. So let's go with magnesium reacting with copper sulfate. Okay, so copper is really far down the reactivity series, magnesium is quite high up. You put one inside the other. Now, in this case, that's a solid, that's a liquid, or rather, that's a dissolved substance. So that would be the reactant A. You measure the time of that for 1 minute every 10 seconds, and then at 60 seconds, add the magnesium. It might be ribbon, it might be filings, doesn't matter. And as the displacement reaction takes place, you get magnesium sulfate and you get pure copper. Again, the temperature will change. You make a recording of that. And now you can do this actually in the laboratory. And it's not that difficult. It's really, really not that difficult. So that's pretty much energy changes in reactions. There's another type, but it doesn't follow this procedure. And that's it. So until next time, ladies and gentlemen, as always, stay cool. Bye for now.